Based on the control pulses, we can label the conduction range as follows. We can see from the graph that S1 is conducting current starting from the firing angle alpha until the extinction angle beta. Meanwhile, S2 is conducting current starting from pi plus alpha until pi plus beta. In overall, the conduction angle of each thyristor is beta minus alpha. This conduction angle is higher than the conduction angle of supplying a resistive load. Other than that, when we look to a complete cycle of the output current waveform, we can see that the current waveform has a half-wave symmetrical. By focusing on the half cycle only, we can say that the current is flowing in the circuit from alpha to beta. Next, let's compare this half cycle waveform to the output current waveform of a single phase controlled half-wave rectifier with inductive load. Although the wave shape of both current waveforms is different, we can see the range of current flow in both converters is similar to each other. Therefore, we can use this current equation to represent the current equation for the half cycle of the output current waveform of the AC voltage controller with an inductive load. The RMS output voltage of the AC voltage controller can be calculated as follows. Lastly, we will discuss the operation of the AC voltage controller using the integral cycle or on-off control technique. By using this technique, the AC source is connected and disconnected to the load for several cycles at a time. Therefore, the control signal is applied at every zero crossing of the supply voltage waveform to control the number of full cycle of the output voltage waveform. As a result, the firing angle of S1 is equal to 0, and for S2, it is equal to 180 degrees. Based on these firing angles, the wave shape of the output voltage and current waveforms is a full sinusoidal. If we want the thyristors to turn on for 2 cycles and turn off for another cycle, hence we can apply the control pulses as follows. From the graph, we can sketch the output voltage and current waveforms like this. From the graph, the turn-on time is measured from 0 to 4 pi and the turn-off time is measured from 4 pi to 6 pi. If the number of cycles during turn-on is n and turn-off is m, therefore, the period of the output voltage and current waveforms can be written as follows. According to T, we can write the equation for the turn on and turn off time using N and M. Next, we can convert the T value to radian by multiplying T with omega. Eventually, we can calculate the RMS output voltage using this following equation. The duty cycle can also be represented using this equation.